Hi, everybody. Sorry about the schedule change this week, but I'm glad to see a few people joining in. And of course, this will always be recorded as usual. So this week, we are getting into some unit conversions. Normally, well, when I say normally, I don't mean normally in this class, but often if you open any kind of chemistry textbook, including ones we've used in the past for this class, this kind of stuff tends to go at the beginning, right at the beginning of class. The reason that we've moved it back is that it is something that is not, I don't know that I would call it especially difficult, but people definitely struggle with it, and you may as well. It has some math involved that you may or may not have experience with. I know that if you've gotten to this point and you can do Lewis structures and naming and all that stuff, I don't think you'll have any problem with this, but it is going to take some work if it's something you haven't seen before. So we're dedicating the week to working on these types of problems, both in a non-chemistry scenarios and also with chemistry with things like moles that we'll talk about tomorrow morning. All right, so we're going to start this with an example that you see in your handout here, talking about a particular car. A 2018 Fiat 124 Spider can travel 26 miles per gallon of gasoline used. So you've probably heard these types of statistics before, miles per gallon, right? Fuel efficiency, things like that. So 26 miles per gallon of gasoline used. And we know how big the tank is, 11.9 gallons, and we know how much gas cost. This is from, I pulled this out in summer 2019, so it was $3.15. It's a little higher than that now. Now, you can probably guess what types of things we're going to be trying to calculate with this, but we're going to take it slowly step by step and really think about what are these numbers telling us. So first, of the three statements above, circle the two statements that give ratios. So that is, this is to this, right? This number per this thing per this quantity per this quantity. So for that, this would be, I'm going to make this a little bigger. So that's going to be 26 miles per gallon of gasoline used. Okay, right? You can see that keyword per here. And it's also going to be the cost, $3.15 per gallon. There's that per again. There are some other words and phrases that can mean that same thing. So it could have said for each. It could have said something like each gallon costs $3.15, or each gallon of gasoline can take the car 26 miles. So there's a few different ways of expressing that. But the idea is you have two different units in a ratio here, miles and gallons, or dollars and gallons. The middle one here is just a description of the size of the gas tank. So there's no ratio. It's not relating two different units to each other. It's just saying this is how big the gas tank is. So let's write these as fractions. 26 miles per gallon, we could write as 26 miles per 1 gallon. So that's what that would look like in a fraction. And actually, the reciprocal of this is also true. So we could also write this as 1 gallon over 26 miles. That's not how it's written here, so I'm going to leave this here, but that would also be a way of relating miles and gallons. Okay, and then we can do the same thing with the cost here. We can say $3.15, or we could use it kind of as a unit and call it $3.15. And that's going to be also per 1 gallon. And then the third one is a measured quantity, which is the 11.9 gallon. Okay, so now we're going to do a problem that is typical of this chapter, of the concepts in this chapter, which is how many miles can the Fiat Spider travel on a full tank of gas? So it's kind of set up for you here. I'll raise this up so you can see it. Which this number is wrong. We've gotten confused there, sorry. So that should be 11.9 gallons. That's what we got from the information up here. And then what we can do is we can multiply that quantity by the ratio that relates miles and gallons. In this case, that's 26 miles per 1 gallon. And then we can use a calculator to find that answer. I get 309.4 miles. So that's how far it can go on a full tank. And then if we look a little bit at how this is set up, another way we can express this number, 11.9 gallons, is 11.9 gallons divided by 1, because you can divide anything by 1, it means the same thing. The only reason to do that is just to emphasize that gallons is on the top of this fraction. So if we divide gallons by gallons, then those actually cancel out to 1, because anything divided by itself is 1. So we can say gallons divided by gallons is nothing, is no unit. And that means that we're left with miles as our answer. And that's really going to be the key to a lot of the problems in this chapter, following the units, canceling the units that you start with and don't want anymore, and then ending the problem with the units that you do want. And so here are some different ways to express the relationship between miles and gallons. So we can say, in the most explicit way, 26 miles per 1 gallon, or 1 gallon per 26 miles. We can also leave out the 1 here and just say 26 miles per gallon, understanding that the 1 is actually there, it's just not drawn in. We can also do something like this and say there is 1/26th of a gallon per mile. Essentially what that is thinking about 1/26th as the fraction, all being on the top, and the 1 mile then on the bottom. So thinking of 1 divided by 26 as one number. But these are all ways of doing this problem, and any of those conversion factors could be plugged into here as long as the miles and the gallons were on the correct side, top or bottom. All right. So another way that we can use these types of conversion factors is to convert between measurements. So for example, from the metric system to the English system, if we want to know how long something is in inches or in feet, and we want to convert that to centimeters, we need to know one conversion factor here, which is that 1 inch is 2.54 centimeters exactly. We're going to use a lot of these different kinds of conversion factors here, but just so you know, down a little ways in the worksheet here, you can see a nice table that tells you the ones that you need to have in your head for the next exam. So any other kinds of conversions that come up, whether it's feet to miles, or miles to kilometers, or pounds to grams, or whatever, we'll be doing those types of conversions, but you won't be expected to actually know those numbers, those conversion numbers. You should know these, and you should know the metric prefixes that we'll talk about in a little bit. So we'll get to that again. I just wanted to let you know that not everything we talked about today is something you need to memorize, but some of them you do. And one that you do is that 1 inch is 2.54 centimeters. So what that means is, how many centimeters are in 1 inch? Well, it says exactly here, 2.54 centimeters. So let's take a look at which of these conversion factors listed here accurately express that, and which ones do not. So I've got 4 conversion factors here. They all contain the numbers 1 and 2.54, but some of them are the wrong relationship. So remember, there's 2.54 centimeters in 1 inch. So that means the 2.54 always has to go with the centimeters. So that tells us that this first one is wrong. There are not 2.54 inches in a centimeter. And if you're ever confused about this, often what you can do is just think it through. So we can think about, all right, how big is a centimeter? It's about that big. How big is an inch? It's about that big. So 2.54 inches is about that big. Is that the same as a centimeter? No, it's not. So that's got to be wrong. 2.54 centimeters an inch. Yep, that's right. 2.54 inches a centimeter. Nope. And then this one is also a correct conversion factor. It's just the reciprocal of this other one. So for the particular, if we wanted to change length from centimeters to inches, so we have centimeters and we want inches, which conversion factor would we use? Well, we'd want to use one that helped us to cancel or get rid of centimeters and instead have inches. So that means we want a conversion factor that has centimeters on the bottom and inches on top. And so that would be the very last one, which looks like that. So always think first about which unit do you want on the top and which unit do you want on the bottom. And then you can fill in the numbers that correspond. That's a lot easier, and it's going to lead to a lot more correct answers than trying to think about, well, do I multiply by this or do I divide by this? It's because depending on the question, that answer, whether you multiply or divide, is always going to change. But having the units in the right position is always going to give you the correct answer. I hope. I guess always is a strong word. All right, so let's try one. Susie wants to know how long her American flag is in inches. She finds a meter stick and measures the flag to be 152.40 centimeters. How long is the flag in inches? Now, you may have done these types of problems before. It may be very simple and obvious to you whether you need to multiply or divide. But I want to take us through it in this very systematic way because it's going to help when things get a little bit more complicated. So we're going to start with our first given unit here, 152.40 centimeters. And then we're going to think about that we want our answer in inches. So we want to multiply by some factor that allows us to cancel out our centimeters and instead give inches. And since the centimeters started with just a single number, not a ratio, that means we can think of that as being on the top. Remember that divided by one thing. So that tells us that in our conversion factor, we want centimeters on the bottom and we want inches on top. That way, centimeters will cancel and we'll be left with inches. So after you've set up the units, then you can fill in the numbers. We look at this ratio and we say, okay, I know there's 2.54 centimeters in an inch, so I know I need those two numbers, but I just got to figure out where I'm going to put those numbers. So I think about how many centimeters are in an inch. There's 2.54 centimeters in 1 inch. So that means my unit or my conversion factor has to look like this, 2.54 centimeters in 1 inch. And so now I can solve that problem by multiplying through whatever's on top and dividing by whatever's on the bottom. So in this case, that would be 152.4 divided by 2.54. So we get 60 inches for that one. All right, so here's some other ones you can try. This is an example again. Now let's go back and think about that car again and try a little bit more complicated version. So we want to know the cost in dollars of my trip to Grandma's 75 miles away when I take the car. I do not have this car, by the way. I don't even know what that sort of car looks like. So we want to know how much it's going to cost to go 75 miles. All right, so what unit are we starting with in this problem? We're starting with those 75 miles. Okay. We've got all these conversion factors floating around from above, the cost, the fuel efficiency. We're going to use all that stuff. But the unit that we're starting with is what we're given here, that we want to know something about this 75 miles. And in the end, we want to know how much it's going to cost, right? That's what it says right here. I want to know the cost in dollars. So we start with miles. We want to get to dollars. We don't have anything that gives us miles and dollars directly related. So we don't know this many miles per this many dollars. What we know is miles per gallon and dollars per gallon. And you can probably maybe see that there's a shortcut here, but we're going to do it as though there isn't one, just so we can fully work it out. So the way I like to think about this is, okay, I'm going to start with the unit of miles. And I'm going to end with the unit of dollars. But since I don't have a conversion factor that directly relates dollars and miles, I need some sort of intermediate factor or factors, depending on the problem, to get me there. So I'm like trying to find a path from miles to dollars. And so I can go back and look at my conversion factors, and I notice that I have miles to gallons, and I have dollars to gallons or gallons to dollars. So that tells me that I can get gallons right in the middle there and complete my path. I can start with miles, I can convert to gallons, and then I can convert to dollars. So let's see how that sets up. And first we're going to do it just with the units. So we've got our 75 miles. And we want to multiply that by a factor that cancels miles and gives us gallons instead, because that's our next step in our pathway. So we cancel miles, and we instead go to gallons. So now we have gallons. We've converted 75 miles to how many gallons that's going to take. But that's not our final answer, because we want to know how much money it's going to cost ultimately. So we need another conversion factor that relates gallons to cost, or dollars. And we don't usually put the dollar sign at the end, so I'm just going to say dollars. And so in this way, miles cancel, gallons cancel, and we're left with dollars. So when we're converting from one single unit like this, we can always put the unit we want to cancel on the bottom and the one we want to keep on the top. The one we want to cancel on the bottom, and the one we want to keep on top. But if the unit is on the bottom, so if we have a ratio, let's say we have miles per gallon, and we want to convert that to miles per quart or miles per liter or something, then we might have to flip those units. So always think about having the unit on the opposite side of the fraction sign, not necessarily top or bottom, but just the opposite side from what you started with, so that everything can cancel appropriately. All right, so now we have our units all set up, and now we can add in the numbers from our conversion factors above, which I don't remember. So let's go back up and look at them. We've got 26 miles per gallon and 3.15 cost per gallon. So 26 miles per 1 gallon and $3.15 per gallon. All right, so how do you solve something like this once it's all set up? Well, you multiply by everything on the top and you divide by everything on the bottom. And as long as you go from left to right, you can do it in order, or you can not, because multiplication is associative. So we can go 75 divided by 26 times 3.15, or we can go 75 times 3.15 divided by 26. We should get the same answer either way. So 75 divided by 26 times 3.15 is $9.09. And I'm going to round, because that's usually what we do with dollars and cents, is we don't go to a thousandths place there. All right, so that's how you do a multi-step conversion, where you have to go, we have to convert one unit to another unit via some sort of intermediate step. All right, hopefully this is going okay so far. I want you to get a chance to try some of these. Now, these are all examples. Hold on, let me get them in the screen properly. These are all examples where you may not know any of the conversion factors that you need. And you could, since you're going to look up the conversion factors, you could pretty easily find the direct conversion factors, perhaps. So I'm going to give you a hint of not really a hint, but just a way to do this that will test you a little bit more. Make sure that you can do it. So when you do this, try going yards to feet to inches to centimeters. And the reason for that is we might know how many feet are in a yard, it's 3, how many inches are in a foot, 12, and then how many centimeters in an inch, we just learned that, 2.54. So you can do just what we did before, but you're going to have an extra step, an extra fraction in there. Same thing here, milligrams to pounds. We could look up a milligrams to pounds direct conversion probably, but we could also go milligrams to grams to pounds, or maybe even kilograms to pounds. Those of you working in the medical field, you probably have to convert between kilograms and pounds all the time. It's about 2.2 pounds per kilogram. And so that might be a conversion you know in your head. It's not on our list, so it's not one you have to memorize, but you might know that one. And then milligrams to grams to kilograms, you should know those conversion factors from way back at the beginning of the semester. There's 1,000 milligrams in a gram. So your conversion factor is going to look like 1 gram over 1,000 milligrams. And then there's 1,000 grams in a kilogram. So all right, so give those a try and see if you can do them. We're going to work through the next one together because this is an example where we have to actually convert an entire ratio rather than just a single unit. So in this example, we have a speed given in meters per second. And the question is asking for kilometers per hour. So if we think about our path again, we're starting with meters per second, and we ultimately want to know kilometers per hour. All right, so now what happens when we have to convert both the top and the bottom? Well, I think we should think about it as in 2 separate steps. We're going to convert meters to kilometers, and we're going to convert seconds to hours. So let's see how that works with these fractions. So we got this big number, speed of light. And that's meters per second. So remember, meters per second means that many meters in 1 second. That's how fast light travels. It travels this many meters in 1 second. Pretty fast. Okay, so we want to multiply it by a factor that converts meters to kilometers or seconds to hours. It doesn't matter which one we do in which order because we can multiply in whatever order we want to. But we do have to do those separately. There's no single factor that can convert both of those at the same time, at least not that we know right now. But we do know how to convert meters to kilometers. So we make a factor that converts from meters to kilometers, and we want to make sure that kilometers stays on top, and we want to make sure the meter cancels. So the meters are on opposite sides of the fraction, and the kilometers stay on top. Now for our next conversion factor, we're going to deal with these seconds. Now the seconds units are not affected at all by this conversion factor because there's no seconds in here. So this next conversion factor is when we're going to convert the seconds. And since seconds started on the bottom, on our second conversion factor here, we're going to put seconds on top. Right? So that way they cancel because they're on opposite sides of the fraction. And the unit we want instead of seconds is hours. Okay. So if we've done this correctly, we should find a canceling partner for each of our starting units. So meters cancels with this, meters and meters, and seconds cancels over here, seconds and seconds. So now what's left is kilometers on top, hours on the bottom, which is exactly what we wanted, kilometers per hour. And we just need to fill in our numbers and calculate. So meters and kilometers, we should know that by now that there are 1,000 meters in 1 kilometer. And then in terms of time, there are 3,600 seconds in an hour. If you didn't know that offhand, you can calculate by knowing that there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600. All right, so now to solve this, we take this initial big number, we divide by 1,000, and then we multiply it by 3,600. That should give us the speed of light in kilometers per hour. So I'm going to run that calculation. And it is a very big number. I'm just going to keep it at the ones place here, but we've got 1,079,253 kilometers per hour. Okay, now with these types of practice, there is a conversion practice worksheet for you to work on. It's also helpful to go back and do these, even though we did them together. Just take the paper by yourself and kind of force yourself to do it without any help or without looking anything else up. And that can be a good way to make sure that you can do these. Okay, there's a page here on scientific notation. We talked about this a little bit earlier in the semester. This is definitely something you want to refresh your memory on if it's something you haven't used in a while, because when we get into moles later, we are going to use some very big and very small numbers. So just as a quick reminder, scientific notation, we did talk about it when we talked about precision and measurement, but you have a base, or you have a number and then times a power of 10. And so that tells you the magnitude of the number. So in this case, well, that's a really big one. Let's use one of these examples. So 7,903, we could write that as 7.903 times 10 to the third power. 10 to the third power is 1,000. So that's basically saying this number times 1,000, which would move the decimal place 3 places over to the right and get you 7,903. 515. And then when you have negative exponents, you're going the other direction. So 8.31 times 10 to the fourth would be 0.000831. And a lot of people like to think about these as counting places. So when we go 831, we say, well, that's going to be 4 places to the left because it's 10 to the minus 4. So that's going to be 1, 2, 3, 4. That means the decimal place is there. Those other ones end up being zeros. So that's how that number ends up working out. So you can use this to give some practice. Let me know if you have some questions. If you're good with scientific notation, you don't have to fill all this in. This is really just review for those of you who maybe haven't thought about this in a while. All right, and then the last thing I think. Yeah, last thing tonight, we're going to talk about metric prefixes. So we talked about a few of these earlier in the semester. And here's kind of the rest of the table. I don't know why I'm getting cut off in my video here. Let me try one thing. See if I can get this to show up better. Okay, I think we can see it now. There it is. All right. So here is a list of some of the metric prefixes. These are all useful to know. We will again stick with the most common ones that you do need to know for sure by memory, which are kilo, centi, and milli. But we will use the other ones as well, and we'll be using them more and more. So even though you can look them up, I would recommend committing these to memory if you haven't already. It's a great system because these prefixes are useful for any sort of unit, whether it's meter, gram, liter, whatever, second, anything. And they're relatively easy to remember when you just remember them kind of in order with how many there are. So as you do your practice, certainly look stuff up as you're starting, but by the time you get toward the end of the practice worksheet, hopefully you can start filling these in by memory instead of having to constantly look them up. So when you convert in the metric system, you could kind of do them the same way. So we can, if we want to know 2.5 meters is how many kilometers, we can set up our calculation 2.5 meters times some unit conversion that converts between meters and kilometers. We want our meters on the bottom, kilometers on top. And then we know there are 1,000 meters per kilometer. So we're going to divide 2.5 by 1,000. When we say keep proper sig figs here, what this is really saying is make sure that your answer has the same number of significant digits or significant figures as the number you started with. So if we start with 2.5 meters, we want to make sure our answer also has two significant figures because we want to carry that measurement precision forward. We want to make sure we're still having the same amount of measurement precision. And so that number would then be 2.5 divided by 1,000. Now, if you type this into the calculator, you get 0.0025 kilometers. And that's okay. That is two significant figures, and that's a totally reasonable answer here. You could also express that to be extremely clear. You could express this as 2.5 times 10 to the minus 3 kilometers. Okay. So when you want to go between larger differences in units like millimeters and kilometers, as long as you remember the individual conversions, you should be okay, or the conversions back to the base unit. You can use that base unit to help you out. And so what I mean by that is we can start with 2.50 millimeters, and then we can go from millimeters to meters, and then meters to kilometers. So there are 1,000 millimeters in 1 meter. There are 1,000 meters in 1 kilometer, and then we can divide by both of those. So you don't have to know that there are, for example, 1 million millimeters in a kilometer. That's actually the conversion factor between milli and kilo. As long as you remember that milli is 10 to the third of the base unit and kilo is 10 to the third more, then you can set something up like this. All right. So hopefully you can start working through these. It does take practice. If it's something that you've struggled with before, don't let your previous expectations, don't just sit down with thinking like, I can't do this. Every time I look at these things, I can never do it. This is the time. This is the time you can do it. I know you can. Come find me tomorrow in lab if you're on campus and ask for help, or send me a message on Discord or an email. We can meet over the computer. You can set up a time in office hours. There's lots of ways that I can help you with this. If you don't want help from me, there's a tutoring center on campus that can help you out. I've seen lots and lots of people become very good at this when they thought they could not do it. So I know you can do it. It's going to take a little practice, but if you've done other stuff in this class this semester, you can do this too. All right. Well, I'm going to stop there for the evening, and I'll come back on tomorrow morning at 9:30. We'll talk about density and moles. So I will see you then. Have a good night.